Okay, so you've brought us a really interesting topic today, cloud seeding. We've got some sources here, mainly looking at the Wikipedia overview.
That's right.
And our mission, I guess, is to really unpack this, figure out what it is, how it works, its history, and maybe a touch on some of the debates around it.
Exactly. Cloud seeding, um, at its core, it's really a weather modification technique.
Right.
People use it to try and change the amount or type of precipitation. So you might want more rain, maybe more snow,
Or less hail, maybe.
or less hail. Yeah, or even clear away fog sometimes.
Yeah.
But usually the main goal is boosting rain or snow.
Okay, so how does that actually, how do you do that? What's the mechanism?
Well, it basically boils down to putting specific substances into the air.
Mm.
These act as cloud condensation nuclei or ice nuclei. Think of them as little seeds.
Seeds for clouds.
Sort of, yeah. Tiny particles that water vapor can grab onto to form droplets, or that help ice crystals form.
Interesting. So what kind of substances are we talking about? What are these seeds?
The common ones, historically, have been silver iodide, potassium iodide, and dry ice, frozen CO2.
Right.
But lately, there's been more use of hygroscopic materials, things like table salt, actually.
Table salt.
Yeah,
Seriously.
because they naturally attract water molecules. It helps droplets combine.
Wow. Okay. So it's not always about freezing things. Sometimes it's just about getting water droplets to bulk up.
Precisely. And there are the sort of two main ways to think about it. There's static seeding,
Okay.
which is mainly about creating ice particles in those supercooled clouds, where water's liquid below freezing.
Right. I remember hearing about that.
And then there's dynamic seeding.
Mm.
That's more about boosting the energy in big convective clouds
Boosting energy. How?
by triggering freezing.
Hmm.
When water freezes, it releases a tiny bit of heat, latent heat.
Oh. Okay.
And in a big cloud system, that little bit of extra heat can make the cloud more buoyant, help it grow taller, and potentially drop more rain.
Got it. So you're kind of kickstarting a natural process. How do you actually get these materials, the silver iodide or salt or whatever, up into the clouds?
Just several ways.
Yeah.
Aircraft are pretty common. They just fly right through the cloud, releasing the stuff.
Makes sense.
Or you can use ground-based generators.
Mm-hmm.
They sort of release the agents into the upward air currents.
Okay.
And then there are newer approaches,
Mm.
things like using drones to deliver electric charges, or even experiments with infrared laser pulses.
Drones and lasers. Okay, now that sounds like science fiction almost. Let's dive into those methods a bit more. Maybe start with the salts and the more traditional stuff.
Sure. So like we said, silver iodide, potassium iodide, dry ice, those are the classics. Liquid propane is another option too. It can actually make ice crystals form at slightly warmer temperatures than silver iodide can.
Oh, interesting.
But yeah, the hygroscopic stuff, like salt, is definitely gaining traction. The thinking is you get the best results for increasing snowfall
Hmm.
when the cloud temperature is between, say, -20 and -7 Celsius.
Right.
And silver iodide works well there because its crystal structure is so similar to ice. It basically gives the water molecules a pattern to freeze onto.
A template.
Mm.
Okay. Now, tell me more about these electric charge drones. That sounds really different. How does that work?
Yeah, it's fascinating. The UAE, the United Arab Emirates, they've been really pioneering this since around 2021.
Okay.
They use drones equipped with special instruments, sensors, that emit electrical charges. They fly pretty low.
And what does the charge do?
Well, the theory is that the charge affects how the water droplets interact in the cloud. It encourages them to collide and merge, basically, get big enough to fall as rain.
Huh.
They actually pointed to a big rainstorm in Al Ain back in July 2021 as an example where they think this method played a role. Got quite a bit of rain.
So instead of adding a physical seed, you're using electricity to kind of nudge the droplets together.
That's the idea, yeah.
Yeah.
A totally different mechanism.
Wild. And the lasers.
Eh.
Infrared laser pulses.
That was more experimental. A project in Berlin back in 2010. Researchers from the University of Geneva.
Right.
The idea there was that firing these infrared laser pulses might cause trace gases in the atmosphere like sulfur dioxide, nitrogen dioxide, to clump together and form new tiny particles.
And those particles would then act as seeds?
Potentially, yeah,
Ah.
act as cloud condensation nuclei. But it was very early days, kind of a proof of concept thing.
Okay, so we've got a handle on the different techniques. But here's the million-dollar question, right? Does it actually work reliably? Because you hear so many different
Oh,
things.
yes, that is the central debate.
Yeah.
It really is. Despite, decades of work, the effectiveness is still very much debated. Studies show mixed results.
Mixed results. Yeah, that sounds familiar in complex science.
Exactly. Even that U.S. Government Accountability Office report from December 2024 pointed this out.
Mm.
Just mixed results improving a significant increase in precipitation.
Can you give some examples? Like, what did some key studies find?
Sure. Well, there was a big one by the U.S. National Academy of Sciences. They basically couldn't find statistically significant proof that routine seeding really boosts precipitation much. One of the researchers, Jerry Bradley, he sort of said, look, maybe under very specific conditions, in just the right place, you might squeeze out a tiny bit more rain or snow.
A tiny bit.
Yeah, but that's very different from having a reliable tool that works consistently.
Right.
Although, interestingly, there was the Wyoming Weather Modification Pilot Project. They looked at similar data, but their conclusion was a bit more optimistic, suggesting seeding could maybe add up to like 3% to the snowpack over a season, max.
3%. So even the potentially positive results sound quite modest sometimes.
That's often the finding, yeah. And another big report, this one from the U.S. National Research Council in 2003, basically said, look, after 55 years of trying this stuff, we still don't have scientifically acceptable proof of significant effects. They admitted we understand weather better now, but the proof for seeding, still lacking.
Wow. 55 years and still uncertain. That really says something about how complicated weather is. Any other studies paint a similar picture?
Yeah, there's a 2010 study from Tel Aviv University. It suggested the common materials, silver iodide, dry ice, probably have very little impact on overall rainfall amounts.
Okay, so that leans towards not very effective. But you said it's debated. So what's the other side?
Well, you have folks like Jeff Tilley from the Desert Research Institute. In 2016, he argued that newer tech and research are producing reliable results. He positioned it as a dependable, affordable water source for some places.
Right.
And even back in 1998, the American Meteorological Society stated that in some specific cases, like over mountains with supercooled clouds, seasonal precipitation had been increased by about 10%.
10%? Okay, that's more substantial than 3%, so the picture is definitely murky.
It really is. You've got this whole spectrum of findings.
What about, like, high-profile attempts? I remember hearing about the Beijing Olympics. Did they try to use cloud seeding to stop rain for the ceremonies?
They did, yes. China definitely deployed cloud seeding efforts around the 2008 Games, hoping to prevent rain during the opening and closing ceremonies.
And did it work?
Well, that's disputed. It's really hard to say definitively if the seeding caused the lack of rain, or if it would have been dry anyway.
Oh.
As one expert, Roelof Bruinches, put it, we really can't just make clouds or chase clouds away on demand like that. Not yet, anyway.
Yeah, attribution is incredibly difficult with weather. Okay, let's shift gears slightly. What about the downsides? Environmental impact, health concerns. We're spraying stuff into the atmosphere after all.
A very important question. Silver iodide, for instance. It does have a moderate health hazard rating, NFPA 704 reading of 2, meaning intense exposure could cause temporary issues.
Okay.
But, and this is key, the concentrations used in cloud seeding are incredibly low. Most detailed ecological studies have found negligible environmental and health impacts because of these low amounts.
Negligible. That's somewhat reassuring. But still, putting silver compounds into the environment.
It's a fair point. But research suggests the toxicity of these silver compounds, as used in seeding, is low. The amounts are tiny compared to, say, industrial emissions of silver, often just 1% of that, or maybe similar to the silver exposure from a tooth filling.
Huh. Okay.
And studies looking at accumulation in soil, plants, water runoff, they generally find the levels are too small to measure above what's naturally there already. Expert panels in California and Australia backed this up in the 90s and 2000s.
So the dose makes the poison, essentially. Low concentrations mean low risk. But have there been any specific concerns or regulatory actions?
Oh, definitely. Back in the 70s, there were estimates of thousands of tons of silver being released industrially in the U.S. each year. That got attention from health agencies and the EPA, contributing to regulations under the Clean Water Act.
Right.
And there are specific cases. Cloud seeding over Kosciuszko National Park in Australia, for example. It's a sensitive area. Environmental groups there have raised concerns about silver affecting species like the pygmy possum or potentially contributing to algal blooms. A similar program there was actually stopped back in the 50s due to environmental worries.
So there is pushback sometimes.
It is. Though it's worth noting, organizations like the International Weather Modification Association point to peer-reviewed studies that generally dispute major negative impacts when seeding is done properly. It's an ongoing discussion.
A balancing act, it sounds like. Potential benefits versus potential risks. Okay, let's rewind a bit. Where did this whole idea even come from? What's the history?
The very earliest notion might be from 1891. A guy named Louis Gathman suggested shooting liquid carbon dioxide into clouds.
1891.
Wow. But the real scientific foundation came later, in the 1930s, with the Bergeron-Findeisen process. That theory explained how ice crystals and supercooled water droplets interact to make precipitation. Understanding that was key.
So the theory came first. Who made the leap to actually trying it?
That really came out of General Electric labs in the 1940s. Vincent Schaefer and Irving Langmuir were researching aircraft icing.
Okay.
And Schaefer had this accidental discovery in July 1946. He was working with a freezer, trying to make a supercool cloud, and he dropped a piece of dry ice in. And boom! Millions of tiny ice crystals formed instantly. He was apparently dismayed at first, then amazed.
A classic serendipitous discovery. What about silver iodide? That wasn't Schaefer.
No, that was his colleague, Bernard Vonnegut, brother of the author Kurt Vonnegut, actually.
No way.
Yeah. Just a month after Schaefer's discovery, Vonnegut found that silver iodide worked too. He was looking through chemistry texts, working with a crystallographer, realized the crystal structure was similar to ice.
Fascinating connection. So Vonnegut's brother wrote about ice nucleation in Cat's Cradle because of Bernard's work.
Apparently so, yeah. It influenced the book.
Yeah.
Both Schaefer's dry ice method and Vonnegut's silver iodide method were developed and patented around that time, 1946, while they were at GE.
Incredible. So when did they first try this outside the lab, on actual clouds?
That was Schaefer again, November 1946. Flew in a plane over Mount Greylock in Massachusetts.
Right.
Dumped about 6 pounds of crushed dry ice into a cloud. And it started snowing.
It worked, just like that.
Just like that. The first documented artificial snowfall? It must have seemed revolutionary.
Absolutely. So dry ice and silver iodide became the go-to methods.
Pretty much.
Yeah.
Especially for supercooled clouds trying to boost winter snowpack or maybe suppress hail or lightning. Later on, there was a revival of interest in hygroscopic seeding, using salts for warmer clouds, based on work in South Africa and Mexico. Try to make bigger drops through coalescence.
Okay. Now, the history also includes some less peaceful applications, doesn't it? Military use.
Yes. Operation Popeye is the main example. During the Vietnam War, 1967 to 72,
What did they do?
the U.S. military used cloud seeding, mostly silver iodide, over parts of the Ho Chi Minh Trail. The goal was to extend the monsoon season, make the trail muddier, and hinder enemy supply movements.
Trying to weaponize the weather.
Essentially, yes. Reports suggest they did manage to extend the rainy period in the target zones. This led directly to international concern and treaties later on.
Right, the ENMOD treaty we mentioned. Were there other military projects? What about hurricanes?
Project Storm Fury, that was in the 1960s. The U.S. military, again, trying to weaken hurricanes by seeding them.
Did that work?
The results were really inconclusive. They seeded a few hurricanes, saw some changes in wind speed sometimes, but couldn't prove the seeding caused it. Plus, later science questioned whether hurricanes even have enough supercooled water for silver iodide seeding to be very effective anyway. Natural variability is huge in hurricanes.
Right. So moving away from military uses, what about government research for, say, water resources?
Oh, there was a lot of that, especially in the U.S. The Bureau of Reclamation ran Project Skywater for a long time, 64 to 88.
Okay.
And NOAA had an atmospheric modification program from 79 to 93. They funded tons of research, looking at winter snowpack enhancement, summer rain increase, working with states, universities, even some international partners.
A big push for a while then. Any major international collaborations?
The World Meteorological Organization had the Precipitation Enhancement Project, PEP, in Spain in the late 70s, early 80s. But the results there were also pretty inconclusive. Maybe the location wasn't ideal. The U.S. Bureau of Reclamation funded lots of university research, too.
But you mentioned funding kind of dried up in the U.S. more recently.
Generally, yeah, federal funding decreased quite a bit, though the Bureau of Reclamation had a smaller program from 2002 to 2006. And that 2003 National Academy of Sciences report actually called for a new national research program to clear up the uncertainties.
Okay, let's look globally again. Australia, you mentioned early trials. What's happened since?
Well, CSIRO, their main research body, did those early trials. The Snowy Mountains one seemed promising.
Right.
But Hydro-Tasmania, the power company, they've run a cloud seeding program pretty consistently since the 1960s over their water catchments. They claim it's successful, boosting rainfall significantly with minimal environmental issues detected.
Interesting. And Europe. You mentioned Austria, Bulgaria.
Yeah, Austria uses it for hail suppression. Bulgaria has a national rocket network for hail. France and Spain tried it for hail back in the 50s, though the success of ground generators there was debated.
Right.
Russia has specialized planes, used them to try and ensure good weather for parades, fight wildfires, help with drought in Crimea. Germany has local groups seeding against hail. Slovenia, too.
So it's pretty widespread in Europe for hail, it seems. What about the UK?
They had an early project, Project Cumulus 4952. It got tangled up in conspiracy theories about a flood later on, but meteorologists debunked that link.
Always the conspiracy theories. Okay, Asia. China, you said the biggest program.
By far, yeah. Massive system. They really believe it helps increase rain in dry areas using silver iodide rockets. They used it before the Olympics, famously induced snow once after a drought.
And they get accused of rain stealing.
There have been reports of disputes between regions, yes. And that 2021 study suggested they used it to clear pollution before a major Communist Party event.
Wow. Okay, other parts of Asia, India, Pakistan.
India's used it in various states during droughts. Pakistan just did its first artificial rain experiments with UAE help and also used their own tech against smog recently. Indonesia used it trying to reduce flood risk in Jakarta. Iran has a long history with it, back to the 40s, and a dedicated research center.
What about the Middle East? UAE you mentioned with the drones.
Yeah, UAE is very active trying to boost rain. They use radar, claim good enhancement rates. Kuwait's looking into it. Israel actually stopped their long-running program in 2021.
Why did Israel stop?
They cited lack of clear effectiveness, the cost, and the fact they'd had pretty good natural rainfall recently anyway.
Interesting decision. Southeast Asia. You mentioned haze control.
That's a big driver there, yeah.
All right.
Using induced rain to wash pollution out of the air. Malaysia does it regularly during haze season and also for low dam levels.
And Thailand, they have that royal rainmaking project.
That's right, started by the king back in 1955. Uses salt and dry ice. They claim it's very successful against drought. It's quite revered there.
Okay. And briefly, North America again. Besides the U.S. research, any ongoing programs?
Yeah, lots of operational programs, especially in the western U.S. states and Alberta, Canada, often funded by water agencies or ski resorts trying to boost snowpack. Wyoming had that big study. California has multiple agencies doing it.
And Canada. Mostly hail suppression.
In Alberta, yes. The Alberta Hail Suppression Project is a long-running program, partly funded by insurance companies. Dates back to successful operations in the 60s.
Okay, this is genuinely global. With all this going on, what about the rules? International law. You mentioned the ENMOE Treaty only covers hostile use.
Exactly, that's the main one. It came out of the Vietnam War concerns. But it specifically doesn't cover peaceful uses, like trying to make more rain for farming.
So for peaceful uses, it's kind of unregulated internationally?
Largely, yes. It falls to national laws, which vary wildly, or sometimes there are no specific laws. ENMOE itself has been criticized for being a bit vague, too.
Which raises that weird question, who owns the clouds? Or the rain that comes from a seeded cloud?
Yeah, it's a legal head-scratcher. There's no clear answer. Back in the 40s, a law review article basically said, owning a cloud is ridiculous. They're just too changeable. Transient. Most legal thinking now leans towards clouds being common property, res communis, like the air or high seas, not something anyone owns until maybe the waterfall. But the status of the moisture in the cloud is undefined. And how does artificially making it rain change things?
Does it change things? If you make it rain, do you own that rain?
Well, some argue that the normal rule rain belongs to the landowner where it falls, shouldn't apply to artificially induced rain. Maybe the cedar has a claim.
How would you even prove how much extra rain was theirs?
Exactly the problem.
Yeah.
It's incredibly hard to quantify. Some places, like California, have laws saying seeded water just follows existing water rights, treating it as natural. But it's legally messy.
Very messy. And all this complexity, the military history, the uncertainty, it probably fuels those conspiracy theories you mentioned.
Absolutely. It's fertile ground. The idea that governments could control weather, combined with the secrecy around past military projects like Popeye, it leads people to believe weather manipulation is happening secretly, for all sorts of reasons.
Like what? What do the theories claim?
Oh, everything from controlling global warming, controlling populations, causing droughts or floods deliberately, testing secret weapons. The chemtrails theory is often linked in, though that's scientifically distinct and debunked.
Right. And you mentioned that LA County ad that stirred things up.
Yeah, 2016. Just a routine public works notice about cloud seeding for drought relief, something they'd done for decades. But the word classified in the ad copy, just meaning as a classified ad, got misinterpreted online as proof of some secret, widespread program.
Shows how easily things can get twisted.
Wow.
Well, this has been incredibly thorough. We've gone from, the basic science to the history, the global spread, the effectiveness debate, environmental questions, legal tangles, even conspiracies.
It really covers a lot of ground, doesn't it? Cloud seeding isn't simple. It touches on atmospheric science, history, ecology, law, politics.
It really does. It's definitely not just a straightforward fix for the weather.
No, far from it.
So, maybe a final thought to leave our listeners with. As we face growing pressure on water resources globally, and this technology continues to develop and be used, what are the big questions we need to ask? What kind of ethical frameworks or global rules might we need?
That's the crucial point, isn't it?
Yeah, thinking about the long-term effects, maybe unintended consequences of deliberately messing with weather patterns, and fundamentally, who gets to decide when, where, and how we use this kind of power over our shared atmosphere. Something to really think about.